This video is about derivatives of trig functions, focusing on the tangent function. So the derivative of tan x is 1 over cos squared x, and then using the chain law, the derivative is 1 over cos squared f at x times the derivative of that inside function. So that's when you have a function as the argument for your tangent function. So let's take a look at the first example here. We've got x cubed, which is one function, times tan x, which is another function. Since we have the product of two functions, that means that we need the product rule. So you can set up your chart if you want to with f and f prime, and then g and g prime, which is our new piece here. Oh, and I should add in up here that 1 over cos squared x is the same as secant squared x. Okay, so let's take our derivative here. So we've got y prime equals g times f prime plus f times g prime, and then we can rewrite this so it looks a little bit nicer. You could find a common denominator and add them together, but it's not necessary to do that. Okay, let's look at the second one. Here we've got y equals cotan x, which is actually a reciprocal trig function. So we can write this as y equals tan x to the minus 1. So here we've got an application of the chain rule where tan x is the inside function. So to take the derivative, we're going to bring the exponent down, keep the inside the same, take away 1 from our exponent, and then we're going to multiply by the derivative of our inside function, which is that tan function. Then we can put everything together. We've got minus 1 all over tan squared x cos squared x. And you can actually, wouldn't be necessary for a test or exam in this course, you can simplify it to minus cosecant squared x. Kind of a fun exercise in a trig identity to prove that those are equal to each other. Okay. Let's go on to our last example here. Here we've got another application of the chain rule, except this time our tan function is the outside function and root x squared plus 1. Okay, so we're going to start by taking the derivative of tan and leaving the inside part the same. Now our next step is we're going to multiply by the derivative of that inside part. So I'm just going to write this up here. D by dx of root x squared plus 1. Here I really have another application of the chain rule, so I'm going to bring my exponent down, take away 1, make it a little bigger. Oh, that didn't work. And then I'm going to multiply by the derivative of the inside, so I'm going to multiply by 2x. So this would all simplify to, let's see, I've got a 2 and a 2, those would cancel out, and then I would just have x over x squared plus 1 square root it. So now, put this in a little bubble here, now I'm going to multiply by that derivative of my inside function so that I've fully applied the chain rule, and then I can write my final derivative with all of the pieces together. So x over the root of x squared plus 1 times cos squared of x squared plus 1. Take a look at the exercises in 14b and 14a, focusing on the ones